Hello, this is Alexis May for AI Med, and I'm pleased to be joined by a special guest, Moshe Becker, CEO and co-founder at RADLogics. Moshe, great to have you with us today.
Thank you, Alexis. Good to be here.
Now, Moshe, as you know, a big focus of the AI Med Talk series over the last few months has been on the response to the global health crisis. Could you tell us, to start off, a little bit about what RADLogics have been doing around COVID-19?
I'll be glad to tell you a little bit about this. I actually have to provide some background context. So, as one of the pioneers in this domain, I co-founded the company 10 years ago. We've been developing AI solutions for medical imaging analysis for all those years. And we happened to focus over the last few years on actually chest-related type of clinical applications. And one more thing that worked in our favor leading to COVID-19 is that last year we actually had our first deployments in China. I think we are the only non-Chinese company who actually has deployments in actual hospitals. In China. We actually publicized this at RSNA last year, that we signed a distribution agreement with a teleradiology service provider in Suzhou. It's a suburb of Shanghai, which serves 500 plus hospitals. So at the get-go, towards Chinese New Year, we were actually deployed and constantly getting chest CT cases processed by our platform in China. And what we noticed early February is that there was a surge in actually the number of chest CTs that had been performed in those hospitals, and we couldn't tell what was going on, and the Chinese would not tell us. Okay, initially at least. And then we looked at the results. We noticed something very strange that we've never seen before in terms of clinical findings. So our Chief Medical Officer, Dr. Patrick Browning, also co-founded the company, and other of our other advisors in the US looked at that and said, this is strange. We kind of like never seen anything like this. Okay, to make a long story short, a few days later, with our Chinese counterparts, it was obvious that we are seeing a new kind of a disease that we've never seen before. And strangely enough, the solution that we had there, which was actually related to lung cancer related clinical findings, was able to detect small patches in the lungs, okay, so-called ground glass opacities. This is kind of like the clinical term, that we've never seen before in quite that shape or form or location and so forth and so on. So this is like the heads up we got on being able to actually see, detect, and measure early stages of COVID-19 inflammation in the lungs. It took me a week to figure out that this is something which was very substantial. Again, we talked to our obviously Chinese counterparts and colleagues, and we realized we're onto something very, very significant. At which point, I made the decision that the company stops doing any other kind of development, and we focus all of our resources, our entire algorithm team, platform, deployment, you name it, on COVID-19. I think back then it didn't even have the name COVID-19. That came like maybe 2 weeks later, okay? So since then, we've been exclusively focusing on developing solutions for early detection and quantification of COVID-19 phenomena in the lungs. For both, started with CT. We had a publication again early on in the game on March 10th on CT. That was the first thing that we focused on, and then about a month later, we had an X-ray, similar concept based on our already trained networks for other diseases in the X-ray that also manages to detect and quantify the extent, that's actually the clinical term of the disease, of the inflammation in the lungs on X-ray. That was the setup that then provided us with the basis to start a global campaign, okay, to launch this at scale. And now we are deployed in many different countries, including Brazil, Russia, China, India, Serbia, Italy, and also now the US, and we'll talk about this in a second. Initially, we saw in all these countries a very similar a situation in terms of our ability to detect and quantify the disease. Again, it's not possible to 100% firmly distinguish between COVID-19 and other kind of inflammation in the lungs, as you probably know.
Mm-hmm.
But the ability of the system to triage cases that are suspected of being COVID, and then when it's verified, provide the quantifiable information that really helps in the disease progression management and patient management through the hospitalization phase, were found to be extremely valuable and sought after everywhere around the world. Same situation, same pain points, same solution works everywhere. So since like what seems literally as an ancient history 3 months ago, okay, we have further developed our solution, and a key element here is one of our distinguishing technology. I would say part of our secret sauce is our ability to continuously learn from actual use. So if you just start today, as an example, and look at some publicly available data sets, and you're trying to build a COVID-19 solution for CT or X-ray, very soon you can actually have something that works, okay, and you can actually show some initial results. It is a far cry from the actual thing that doctors and hospitals need. This is what we found. This is like looking back at our solution maybe 2 or 3 years ago in terms of lung, cancer-related stuff. So what we do continuously, we actually look at the output of running the system in multiple sites and getting the feedback from the doctors, from the final reports. Okay, we see that. Okay, so we are able to continuously learn and continuously improve the algorithms that are more precise, and mostly in the sense of having fewer false positives. This is always the tricky thing. It is very easy to do a system that has very high sensitivity. Okay, you just tune it to essentially have a very high probability of flagging any case as positive. That's almost trivial, right? The tricky part is to minimize the amount of false positives, which really puts a burden on the radiologists and clinicians that need to go through that and say, this is wrong, this is not true, this is not a real case, or whatever. That's really what it's all about. So both for the value propositions of triage, prioritizing cases of positive findings, which we have, and the quantification aspect, being able to manage the disease over time, we found that our unique solutions of continuously improving the algorithms and improving the specificity, the false positive rate, provides a system which is actually workable and useful for day-to-day clinical use. Without that, it's a nice demo, it doesn't cut it.
Moshe, thanks so much for sharing that fascinating story. You touched on so many points there. I mean, within the time constraints that we have for this talk, I don't think we can dig into them. I guess my question, you've talked a lot about your experience of deployment.
Right.
Just to finish off, our global community always keen to hear about experience of that sort of thing. from that experience, what would you say are your key lessons learned that you would want to share with the AI Med community across the world?
Three main points. Okay, one is these tools are not to be confused with anything. You know, we had that talk, very common 3 or 4 years ago, that AI was actually going to replace clinicians or radiologists. Okay, lesson number one, forget about it. Okay, not going to happen for the foreseeable future. This is my insight based on our experience, in particular in COVID-19. This is a supporting tool. It helps in managing, patients, as I mentioned, and also allowing when there's a surge of incoming suspected patients, to get to treat those that are more likely to be actually sick sooner rather than later. And we're talking about a 10 or 100x factor in turnaround times. Okay, this is lesson number one. Lesson number two relates to my previous comment that if the system is too noisy, as we call it, or provides too many false alarms, okay, very soon the clinicians get tired of it and they would not use it. They would just not use it because it creates more, I would say actually more work for them than actually saves it. And even in the triage case, if it's oversensitive and not specific enough, then they just lose patience. This is lesson number two that we learned. And thirdly, and perhaps most importantly, it's the issue of how do you integrate this output of the analytics, of the AI, all these sexy algorithms into the existing working environment of the clinicians or radiologists. Again, it sounds like it's, the most trivial thing. Okay, I have the output of the algorithm. What's the problem of just putting it, in front of the radiologist for review or and use? Turns out it is one of the biggest challenges in this industry. And we actually put a lot of effort at RADLogics creating a platform that solves this workflow. We call it like a zero-click workflow solution, where we actually patented it both in the US and Japan. So the idea here is that the information doesn't show up on a separate app that needs to be learned, or in a separate screen, or in a separate in an element or an object which is outside of the existing workflow of the radiologist. We developed something which is seamless. It just goes directly into the same real estate. I call it real estate. The two screens that radiologists use to review cases. The viewer screen, where they review the images, and the reporting screen, where they actually dictate or type the results. So we put a lot of effort into creating this workflow platform solution that provides all the great output from the AI algorithm directly into the existing reading environment of the radiologist, so they don't have to look for it. They can readily assess it, review it, and then use it in their final report to actually save time and improve accuracy. Those are the three main things that I would point out.
Thanks, Moshe. It's been really great talking to you. Again, I think there's so many things that we could pick up on, but that is all we have time for today. So thank you again for joining us. And thanks to everyone for watching today. As ever, please remember to like, share, and subscribe. And you can check out more AI Med talks at ai-med.io.
Thank you, Alexis, for inviting me. Pleasure.